Okay, so as Murray mentioned, this is the youngest ARA the PAWR platform. So what I'm going to do is to share a very quick overview about the Living Lab, and then I'll talk about probably with a little bit more focus on rural applications, and then end with a thought about how you can all help shape potentially the execution of the infrastructure deal. We probably have heard a lot of discussion about rural broadband as a challenge to be addressed, but I think here I want to kind of share that it's actually a great untapped market segment for look at innovation applications and so on. Right. So to that end, I want to start with a general discussion about the broad set of applications that you can envision if we can actually get rid of the make broadband available anywhere in the rural regions. So, I mean, there are many ways of looking at applications, and one approach could be look at their specific requirement about the throughput or their tolerance on latencies. With that in mind, we can think of at least four broad categories of applications. One is the IoT application, right, that does not need a lot of throughput, also can tolerate certain delays. And then there's the other extreme that need a lot of capacity and also ultra low latency in terms of mixed reality or extended reality applications. And then another sector on systems control, usually do not need a lot of throughput, but actually are sensitive to any non-negligible latency in general. And then the video applications that doesn't need ultra low latency in general, not like sub-millisecond latency, but also tend to have a requirement on high throughput. Now, within this framework, you can actually come up with many applications that folks have been exploring. For example, in agriculture, there's a lot of study of looking at using LiDAR sensors for understanding the nitrogen in the plants, and also so that this sensing result can be used to drive both breeding operation, but also for day-to-day farm practice. And then there's the discussion of using drones for animal herding in the remote areas, like Midwest or even Great Plain areas. And then, of course, a lot of discussion about connecting automated ground and aerial vehicles for precision agriculture. And then in the industry of like breeding, right? Breeding plant industry, there's a lot of actual activity to look at high resolution cameras for phenotyping and genotyping studies. So those are some examples in the agriculture space. In education, actually, there's a lot of need, in fact, actually needed for AR, VR based education practice in the rural regions, so that we can bridge the education gap we see today in our communities. So these are just some examples. There are actually many other use cases you can think about in terms of agriculture and education, not to mention other application domains. But if we look at where we are today, right? So this come back to the challenge we face today, despite these huge opportunities out there. If we look at rural US today, actually 39% of the areas do not have broadband access. And as exciting as digital and precision agriculture, most farms are not connected at all. So I guess one mission for the ARA project is to build this living lab so that we can start developing technologies that can be brought to the rural regions to solve some of the challenges we have, but also to really enable the exploration of some of the exciting applications we just briefly touched on today. So here's a very quick summary about what the planned ARA deployment looks like. So at a very high level, we expect to have two layers of technologies and platforms made available. Could be as early as later this year, also I'll briefly touch later. So one is the long distance, high capacity wireless backhaul solution, which we call the ARA haul. So that's going to span a good part of the central Iowa across 3 counties, across an area of 36 miles, covering spanning 6 rural cities, plus one of the state-of-the-art crop research farms run by ISU. And then at each of the locations you see on the map, we will deploy advanced access network platforms. And then in the state of Ames, where ISU reside, we would have a little bit more denser deployment across city utilities, the research farms, and so on, research park, and potentially a public safety tower. So besides, the city schools covered, this will also expect to cover a producer farm. It's a crop and turkey farm here, as well as the U.S. Farm Progress Show, which is actually held every 2 years. This is an event that usually happens in August, September, and pretty much all the ag, farmers, the ag vendors, they all come here, basically across the world, they all come here and then kind of demonstrate their latest, progress in technology and so on. One thing that so far there's no wireless company coming to these shows. Hopefully, that will change, in a few years as the agriculture, the use of broadband for agriculture actually start to gain momentum in practice. So just a little bit more on the details. So we will share the slides. I'm going to dive too much into the details on the bike haul, the ARA bike haul. This is where you can find high capacity research platforms that operate at a diverse spectrum band from the free space optical at 194 terahertz to E-band 70, 80 gigahertz to 11 gig or 18 gigahertz microwave band. We also expect to include new SATCOM platforms as part of backhaul, as well as the access network solutions. On the access network side, this is where you can find both commercial and research SDR systems that's operating at the low UHF, including two-way wide space band, the mid band about 34 to 3600 gig megahertz, and the millimeter wave band. Given its focus on the rural applications, the deployment will actually leverage. You would see the deployment across, both crop and livestock farms. Also include state-of-the-art farm facilities such as green mill, a biorefinery, and some of the barns. And it's going to include, both those big ag machines as well as ag robots, potentially drones, hundreds of cameras, nano sensors. Also similarly, you can find similar sensors and cameras in the livestock farms. There will also be environmental sensor and control systems that's already there. So you can actually try out feedback control systems in the real world, real environment. And there's also a solar farm that's going to be available as part of the within the ARA deployment area. So that's on agriculture. In terms of rural communities, we have been making progress in really engaging the cities and communities to flesh out ideas on how they can actually leverage the ARA type of connectivities in city services and so on. So you would, I think we would expect to see deployment along the water towers, city water wells, potentially the municipal airport and traffic infrastructures. And then on the mobile side, there will be likely fire trucks, police cars, school buses, and then of course the more traditional user equipment in the schools and communities. So for folks not kind of new to Iowa, this is where you can find clear 4-season weather, as well as diverse rural terrains that provide really a good set of diverse environmental and channel environmental setup and conditions for understanding channel behavior over time and space. So that could be some really early experiment we can actually do once the platform is up and running. So that's kind of overview in terms of where we are. So the team has been working very hard. Some of them are actually here on the call too. So we hope that, assuming that the supply chain challenge and the other budget challenge will not stop us too much, we would expect to have 4 base station and core sites deployed hopefully by actually around this summer, if not sooner. So they include the ISU Wilson Hall, the research park where you can find a lot of research centers from John Deere, Vermeer, Cummins Aerospace, and so on. Then the state-of-the-art Curtis Farm, that's a crop farm where you can find thousands of cameras deployed every year. And then the BioCentury Research Farm area. So those are the 4 sites that hopefully will be up and running pretty soon. And as part of the deployment, we do expect the signal to cover the show center, the US Farm Progress Show Center, that actually, I think this year is going to be held here around August, September. So there may be an opportunity for us to think about, what we can do over there. And if you have any ideas, we'll be interested in participating. We would love to hear from you. So those are the access network side. But so we would also, as part of the deployment, there will be one link that's going to, between the research farm and Wilson Hall. That's going to include the free space optical, E-band, and microwave band link that's going to be available. So as part of the, once this phase 1 deployment completes, we hope to be able to support in-depth link measurement, link and channel measurement about both the long distance high capacity backhaul, but also the access channels in the rural settings. We also expect to support some baseline access network, backhaul, and end-to-end broadband application studies. Some canonical, some of the example applications we hope to focus on in the near term, potentially around summer, if we finish everything else in time, would include the following. One is this like Phenobot, the robot for phenotyping studies. So this is a robot actually that carries up to 16 high resolution cameras, which can generate as much data as about 800 megabytes per second of data that need to be ideally need to be processed in real time in the cloud in certain cases, right? So there's going to be a lot of interesting underlying technologies that can be studied as part of the application trials. And then there's the camera-based livestock health monitoring. So that's going to be likely within the ARA coverage. This is a beef nutrition farm northwest of the city of Ames. So that's another kind of livestock farming studies that can be enabled. And then in collaboration with industries such as partners such as John Deere, we hope to probably demonstrate the 4th generation of autonomous agricultural solutions. And in the long term, you can look at the scenario where rich data set from the autonomous vehicles need to be processed in real time in the edge and cloud, and then provide feedback control decisions to the vehicles itself. So here's a link. If you Google, actually, if you Google John Deere CES 2022, that can give you, take you to a link that can give you some insight in about what kind of agriculture automation can be done today without super high capacity link to the field. From there you can actually see, if you can provide a high capacity link to the field, what can be accomplished. There's actually a lot of those use cases that we can look at.
Okay. I think we're going to have to go ahead and wrap this up, Hongwei, just so we make sure to have time for everyone.
Yes, just 1.5 minutes. Yeah. So another use case will be the AR-based ag education that will be tried out as we deploy. I want to just conclude with this, with one thought about the, infrastructure deal, which is, the execution of the program is still being sorted out. All right. This is where everyone can actually contribute to the planning of the program execution. 65 billion will be invested into broadband. I think some of the technologies we talk about here can be actually ready, potentially be ready in about 2 to 5 years if we get some to work with industry partners and like some of you here. So just give you some numbers you can take away, in terms of agriculture impact, right? Any 1% increase in 25 downlink, 3 meg BPS uplink connection can mean 3.6% increase in corn yields. Similarly, just 1% increase in broadband adoption at even lower rate can give you 2.5% decrease in operation costs in agriculture. And for us as a nation, if we can enable broadband-enabled precision agriculture, that means somewhere between $47 to $65 billion of economic benefit to the communities.